Good afternoon, everyone. This is Henry from ASTEM Tutoring again. Today's lesson will be on math, specifically a calculus lesson about how to use integration by parts to solve for an indefinite integral. So, first of all, let's look at something I put up on Desmos, first of all. So, if we have the function y equals x cosine of x, that's this red curve here. If we zoom out a little bit, you can see it's a sine wave that's multiplied by x. It's getting larger and larger as x gets larger and larger. We could find the definite integral using Desmos very simply. Using this integral here from 0 to 5, we can get a value of negative 5.51. But what if we don't have Desmos available? Or what if we want to find the indefinite integral? How can we do that? We would use integration by parts. So let me explain that. Suppose we have this formula. The integral of u dv equals uv minus the integral of v du. So the trick to using this successfully is to choose a value of u that we can easily find the derivative of, du, and we want a value of dv that we can easily integrate once to get v, and then integrate once again. So if we have the integral of x cosine, hold on a second, x cosine of x dx. Well, x, if you take the derivative, gets simpler. It just becomes 1. So that's very simple. So we'll let u equal x. That means du simply equals dx. That means that dv equals cosine of x dx. So v equals the integral of cosine x dx, which equals sine x. Now we have everything we need to apply this formula for integrating by parts. So we can say this equals uv x sine x minus the integral of v du, which is merely sine x dx. The integral of sine x dx is negative cosine of x. So minus a negative gives us a plus, and our final answer is x sine x plus cosine of x plus c, the ubiquitous constant of integration that is in all indefinite integrals. This is how we could use integration by parts to find an integral where it's a product of two quantities that are hard to integrate as one unit, but we can integrate by parts. Now you may be wondering, well, what if the derivative of u gets a little bit simpler, but it's not simple enough, and we have to integrate by parts again? Well, there's a specific method for that, which I will demonstrate and explain tomorrow. But let's finish this lesson by confirming that this is the correct indefinite integral for the original function. So let's graph that on Desmos. Y equals x sine x plus cosine of x. Okay, so now we have this blue function here, and we want to go from 0 to 5. Well, first we need the value at 5. The value at 5 is negative 4.51. The value at 0 is 1. If you subtract, you get negative 5.51, which agrees with Desmos' answer for the definite integral that we started today's lesson with. So again, this has been a simple lesson and demonstration of how to use integration by parts to find an integral that you would not be able to integrate normally. And as a review again, when you're selecting the parts to separate the integrand into, you want to select u to be something that gets simpler when you take the derivative, and you want to select a quantity dv that can be readily integrated once or twice so that you can solve using this formula. If you'd like to learn more, I am available for hire as a private tutor. The first 1-hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. Also, as a thank you for watching to the end of today's video, if you mention the code FREEBOOK when you contact me, at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, especially high school and college students, succeed in school, work, and life. Thanks for watching. Have a good day.